In this video, we'll look at equations that are quadratic in form. What is an equation that is quadratic in form, you might ask? It is not originally a quadratic equation, but an equation that is quadratic in form can be expressed as a quadratic equation after using an appropriate substitution method. In this video, we will be discussing how to use that method. Take this for example, x to the fourth power minus 5x squared plus 4 equals 0. This is not a quadratic equation. However, it is an equation that is quadratic in form. But to be an equation that is quadratic in form, there are conditions that must be met. The variable factor in one term must be the square of the variable factor in the other variable term. The two variable terms here are x to the fourth power and x squared and negative 5x squared. X to the fourth power is x squared squared. Additionally, the third term must be a constant without any variables. Now let's use substitution to solve this problem. Since x to the fourth power equaled x squared squared, I wrote it in that form. Notice how I have two x squared. One is raised to the second power, while the other one is raised to the first power. I can use u to represent x squared. Then I can use u to replace every x squared in the original equation. And there we have it, in a quadratic equation. Having a quadratic equation will allow us to factor easily. You can check the factorization using the FOIL method. The zero product principle states that if the product of two algebraic expressions is 0, then at least one of the factors equals 0. So let's set both factors to 0. Let's isolate u, and u minus 4 equals 0. Add 4 to both sides to get u equals 4. And u minus 1 equals 0. Add 1 to both sides to get u equals 1. Now remember, our goal is to solve for x, not u. So after clearing out the board, let's replace u back with x squared. To leave x by itself, let's take the square root of both sides. Remember to use the square root property. When simplified, x equals either positive or negative 2, or positive or negative 1. Check the proposed solutions by referring back to the original equation. Let's start with the left side. Replace every x in the original equation with 2. In this equation, all exponents are even. Therefore, the negative proposed solutions would cancel out. So we only have to check the positives. The left side resulted in a true statement. Now let's check the right side. Replace every x in the original equation with 1. The right side also resulted in a true statement. The solution set for this equation is negative 2, negative 1, 1, and 2. The solution set is all values of x for which this equation is true. We have successfully solved an equation quadratic in form using substitution. But we're not done yet. We'll be solving one more equation that is quadratic in form, once again using substitution.
The following problem can be found in the Intermediate Algebra for College Students textbook by Robert Blitzer.
It is a little harder than the first problem, therefore I'll focus less on the basics and more on the new variations that come up. Now, although the problem and the answer themselves were in the book, specifically in checkpoint 2, I will give a step-by-step tutorial on how to solve the problem. Although you may not realize it at first, this equation is one that is quadratic in form, meaning you can use substitution to solve it. The variable in the first term, x, is the variable in the second term, the square root of x squared. In other words, the square root of x times the square root of x equals x. Finally, the third term is a constant. Now that we know that this equation met all the conditions it needed to meet in order to be an equation that was quadratic in form, let's identify the exponents. The square root of x is equal to x to the 1/2 power. Let's use any letter, in this case t, to represent x to the 1/2 power. Now substitute every x to the 1/2 power with t to get t squared minus 2t minus 8 equals 0. Next, let's factor our new quadratic equation. We get t minus 4 times t plus 2 equals 0 as the result. Now let's set both factors to 0. Then let's solve for t. On the left side we get t equals 4, and on the right side we get t equals -2. We're not done yet. Remember, we are solving for x, not t. And also remember that t equals x to the 1/2 power. Replace all t's back with x to the 1/2 power. Then square both sides to isolate x. You should get x equals 16 on the left side, and x equals 4 on the right. Since both sides of the equation were raised to an even power, we must check the proposed solutions in the original equation. The proposed solutions were x equals 16 and x equals 4. Let's start with x equals 16. Replace every x in the original equation with 16. Then solve. (16 minus 8 minus 8 equals 0), a true statement, which means (16) is a solution to this equation. Now let's check the other proposed solution, 4. Replace every x in the original equation with 4. Then solve. (4 minus 4 minus 8 does not equal 0. Therefore, 4 is not a solution to this equation. All values of x that make this equation true is 16, so the solution set is 16. And ta-da! We're done! Using substitution, we completed another problem that was quadratic in form.
Remember to keep in mind that substitution is not the only way to solve these equations. There are other methods, but substitution may be the most accurate and reliable one.
I hope this video helped, and thanks so much for watching!